Hello all. I am going to give some inputs about sensors and actuators used in Internet of Things, that is IoTs, right? I am directly going to this slide. I will share a slide here. Let me take a pointer, laser pointer. Sensors and actuators, I am going to discuss about these two things in IoT perspective, right? So, IoT devices are non-standard computing devices that connect wirelessly to a network and have ability to transmit data. So, data transfer is by sensors and actuators. I'll give some block diagram, then only you will understand what exactly this means. Okay. So, this is barcode reader. This is a non-computing device. This is a traffic light widely used in smart cities by IoTs and driverless car. And this is a smartwatch to find our physiological condition like ECG, blood saturation level, that is SpO2 level, and then BP, heartbeat level, everything is collected by this smartwatch and sent to internet wirelessly. So that is called IoT devices. Another example is, so in your home AC, you can control using mobile app. So wherever you are inside the house or outside or in your office or traveling, you can control the AC or switch off the AC, switch on the AC, control the cooling, everything remotely by using this IoTs. So this is a non-computing device. So an example for computing devices are our computer. This laptop is a computing device. Our mobile phone is a computing device. Our hard disk is a computing device. All these things are non-computing devices. So non-computing devices are connected to internet wirelessly. That is called IoTs. That is the definition here. So another example in home automations, this is washing machine, this is air conditioner, this is TV, this is fridge. All these can be connected to internet wirelessly using these IoTs. So that's all about the IoTs. Let me go through the sensors. So sensors actually picks physical phenomena around them, occurring around them, and convert into electrical signal. All of you are aware of this driving. I mean car driving, and there are many sensors are used. I am picking a couple of them. This microphone actually collected sound and convert into electrical signal. For example, fuel sensor means fuel level is calculating and send the data to the driver. If it is empty, there is a red signal is coming out, right? So red signal means the fuel tank is going to empty, you fill it. That is the information. For infrared information, if there is while parking, if there is any block in front of them, the infrared sensor emits light and the time of arrival of light and getting back. So that time is calculating some velocity, velocity is in the velocity of light is 3 into 10 power 8, and time, then you can find the distance, and that data is transferring to the driver. Okay. So like a AC sensor is there, that is a temperature sensor. Suppose we want to make a temperature 26 degrees Celsius throughout the travel, we can make this sensor picks the outside temperature and give the corrective measures so that the inside temperature is always 26 degree throughout the travel. So what is actually actuators? Actuators actually do is the opposite what the sensors do. So collecting signal from sensors and take some actions. Normally it is mechanical action. So consider this water tank. So it is filled by a pipe. So water is filling the pipe, and you might be knowing. So this is overflow marking. Beyond this level, there will be overflow of water, and the wastage of water will happen. So what we are doing is a sensor is picking here. So the sensor picks the water level from here. It can be a proximity sensor or ultrasonic sensor, or it can be LVDT, linear variable differential transducers, to sense the water level. So this proximity sensor is connected to a valve. So this valve is air. So this is actuator. So this is a mechanical part. It can open or close this water flow. Okay. So when it is closed, when it is reaches this red level, it can, this sensor sends a signal, electrical signal, and converted into this mechanical. And so this actuator is closing this valve, and this valve is closing this pipe, the water flow, right? So this is a simple example based on this car sensor for EC, AAA, AE students. How we can control 230-watt or operating device using 5-watt DC supply. You think about it, okay? How can we control 230-watt or more operating devices using 5-volt supply, okay? So the actuator device is responsible for moving or controlling mechanism in a system. So that convert energy into motion. So the energy is used, it needed by source of energy. So it cannot work independently. So it is there should be some energy input. So the energy input can be in the force, so mechanical force, electrical current, hydraulic fluid pressure, or pneumatic pressure. Okay. Some transducer means you might be knowing, you might have studied a lot about transducer in instrumentation subject. It convert one form of energy into another. Some examples are here. Microphone collect audio signal, voice signal, and convert into electrical signal. Loudspeaker the loudspeaker does the reverse of that one. That is electrical signal is converted into audio signal. And this is a strain gauge. Strain gauge means without any force or tension, there is a definite fixed resistance. Suppose it is 10K. When a force or tension is applied, deformation happening in this structure, and so the resistance changes. So this can be connected to a bridge circuit. For example, bridge circuit, and so there is a force is converted into electrical signal. So microphone, loudspeaker. So laser diode means the current actually control the intensity of light output from laser. So current is converted into light. So photodiode does the opposite of what laser diode do. So here the photodiode means absorbing light, taking light from optical fiber and convert it into this electrical signal for demodulation in the receiver. Okay. So transducer, actuator, sensor. The transducer is a device which convert one form of energy into another. The actuator device is convert energy into motion. We studied about, we had seen about this operating of an actuator in a tank. So there is a motion is happening. When the output transfers is converted into readable format, the transducer is called a sensor. So in general, we can make a block diagram of a transducer based on this sensor and actuator. So input energy is here. So sensor that takes input energy and connected to an actuator. So that will move depends upon the energy coming from sensor and out. So in general, the transducer is input energy is converted into an output energy in different form of energy. So most of the case don't need actuators. Moving part is not there. So for example, our microphone, the input energy is sound signal or audio signal and converted into electrical energy. Okay. So Bluetooth or ZigBee. So in IoT device, what we can use, Bluetooth or ZigBee. ZigBee is widely used in IoTs. Why we are going for ZigBee instead of Bluetooth? So range, power consumption, and data rate. So you think about these things. Why the range of transmission of Bluetooth, range of transmission of ZigBee, power consumption, which is a minimum, and data rate. And these IoT devices only transmitting some incident. If some incidents happen, then it will transmit. So you think about high data rate or low data rate is required. So that's all about this sensors and actuators in IoT devices. And ZigBee is widely used network in IoTs. Okay. Thank you very much. Thanks for your listening.